Welcome to the Dispatch module of the A320 RNP AR e-learning. Our objectives in this module are 1. To have a basic understanding of RNP AR procedures. 2. To know how to identify an RNP AR approach chart. 3. To identify the required equipment for RNP AR. 4. To understand operational approval for RNP AR operations. 5. To study ATC flight plan modifications for RNP AR. And 6. To include rain prediction in flight planning. Required Navigation Performance, RNP, is a performance-based navigation that allows an aircraft to fly coordinate-defined waypoints in space in compliance with the required performance level. The level of performance required for a block of airspace or procedure is expressed in nautical miles and defines a position accuracy and integrity. GNSS service is required to provide its navigation accuracy, continuity, and integrity along the flight. For example, for accuracy, RNP1 airspace requires the aircraft navigation system to be able to calculate its position accuracy within 1 nautical mile. A procedure with RNP equals 0.3 nautical miles requires the aircraft navigation systems to be able to calculate its position accuracy within 0.3 of a nautical mile. A RNP AR arrival or departure procedure is defined as a RNP procedure that requires a specific authorization. AR means authorization required. These RNP AR procedures may have the following specifics. It may be designed with RNP values between 0.3 and 0.1 nautical miles. It may follow a curved path at low altitude above terrain. It has a reduced lateral obstacle clearance compared to conventional non-precision approaches. In this example, the RNP AR procedure is charted as RNP Zulu runway 05 AR. RNP AR approach procedures can be designed with various minima depending on the RNP value, from RNP 0.1 to RNP 0.3 nautical miles as depicted on the approach chart. Let's look at some examples for the A320, which is a Category C aircraft. RNP 0.3 approach value 910 feet above mean sea level or 764 feet above ground level. RNP 0.2 approach value 820 feet above mean sea level or 674 feet above ground level. RNP 0.1 approach value 520 feet above mean sea level or 374 feet above ground level. For flight planning and before departure, the minimum required equipment for RNP AR operations is indicated in the FCOM, in Special Operations, and in the Minimum Equipment List, MEL. Some inoperative equipment at dispatch may lead to RNP AR capability limitation or capability loss. The required equipment for RNP AR operations can be found in FCOM, PRO, SPO, RNP, RNP AR. At all times after departure, the A320 RNP AR capability needs to be monitored by the flight crew. Warnings or cautions may be triggered, indicating system malfunctions that the crew will need to respond to. Dispatching RNP AR flights with inoperative equipment is not recommended. RNP AR operations require the airline to have a specific operational approval from its National Civil Aviation Authority. The operational approval takes into account the following requirements. The aircraft meets certain airworthiness certification standards. As indicated in the Aircraft Flight Manual, the A320 is compliant with EASA AMC 20-26, FAA AC 90-101A, and FAA AC 20-138C. RNP AR operations are available for departure, approach, and missed approach. The FMS database has been validated by the airline. The flight crew and dispatchers have received a specific training. The RNP AR approach charts are available to the crew. A rain prediction program is used, and an RNP AR monitoring program is implemented. In the ATC flight plan form, information on PBN capability is indicated in both fields 10 and in 18. If PBN levels can be met, the letter R is used in field 10A, and the levels shall be specified in field 18 with the indication PBN. In case of several PBN capabilities, they must be concatenated in item 18. For RNP APCH, the operator should select S1 or S2. For RNP AR approach, the operator should select T1 or T2. Note, aircraft capable of RNP AR APCH with radius to fixed legs are also capable of RNP AR APCH without radius to fixed legs. The GPIRS integrity is a direct function of the number of satellites of the GNSS constellation in view of the aircraft. Airbus recommends the use of a ground-based prediction program in order to check GPS primary availability at the estimated time of operation in any of the following cases. For RNP AR operations with less than 24 satellites available. Within constrained environment areas. An environment area is considered constrained in the case of possible masking of GPS satellites in mountainous area, when the GPS mask angle is greater than 5 degrees. In all other cases, GPS primary is available 100% of the time worldwide, and also if it's required by a national authority. A ground-based prediction program shall qualify the GPS coverage along a given RNP AR procedure at the specified airport within a given time slot. The prediction is based on the almanacs and takes into account the notice advisory to Navstar users, NANUs, that indicate the functioning state of satellites. The almanac consists of orbit and status information for each satellite in the constellation and information to relate GPS-derived time to Coordinated Universal Time, UTC. A NANU is a message that provides updates on the general health of the individual satellites in the GPS constellation. The ground-based prediction program also takes into account potential terrain masking with an altimetry shadow computation. Note, Navstar GPS, Navigation Satellite Time and Ranging GPS, is the original name of GPS. These images show your RAIM as an example of a ground-based prediction program. The operator can receive an automatic Your RAIM prediction email for RNP AR prediction, and possibly an additional email for RNP APCH airports, if any, on a daily basis. Dispatchers can also check the predictive performance capability at a given airport for RNP AR departures and/or approaches via Your RAIM prediction website. The trajectory prediction mode provides RAIM prediction for a given trajectory on a given airport at a given time and for a given prediction duration. The operator should ensure sufficient means are available to navigate and land at the destination or at any destination alternate aerodrome in the case of loss of capability for the intended approach and landing operation. During PBN operations, if a destination alternate aerodrome is required, the pilot in command should only select an aerodrome as a destination alternate aerodrome if an instrument approach procedure that does not rely on GNSS is available either at that aerodrome or at the destination aerodrome. Note, the same regulation applies for RNP APCH and RNP AR. The flight preparation shall include the following requirements for RNP AR procedures. Verify that the OAT at the expected time of arrival is above the minimum published temperature for RNP AR approach at destination or alternate if applicable. Verify that local QNH is available for RNP AR approach at destination and alternate. Check for significant weather and wind conditions along RNP AR trajectories. If an RNP AR departure procedure has an engine out standard instrument departure, EOSID, the performance data must be made available to the crew from dispatch. This list is a summary for flight planning of RNP AR operations. Plan an aircraft certified for RNP AR operations and verify the minimum required equipment. The airline must include the RNP AR procedures in the navigation database validation process. The FMS navigation database must contain up-to-date RNP AR procedures. Navigation and terminal charts must be up to date. RAIM prediction must be checked. The ATC flight plan must be filed correctly, and performance and weather minima must be checked. We have now covered our objectives for this module and the whole of the course. In this module they were 1. To have a basic understanding of RNP AR procedures. 2. To know how to identify an RNP AR approach chart. 3. to identify the required equipment for RNP AR. 4. To understand operational approval for RNP AR operations. 5. To study the ATC flight plan modifications for RNP AR. And 6. To include RAIM prediction in flight planning. Thanks for taking the time to go through these 10 modules with me. You can retake any of them again if you want to before doing the quiz. I wish you the best of luck with the quiz and hope you get your certificate at the end from the Achievements area in NavBlue Academy. Goodbye.